Okay, guys. Yes, thank you for joining the lecture this early hour. So I think we can start and does not wait for more people. So let me share these slides. Okay. And okay, guys. So if there are no questions, then let's move on. So today we are going to talk again about commodity taxation, and the topic is optimal commodity taxation. So we already know that all taxes, including commodity taxes, are distortionary. And so we learned during the last lecture the analysis of tax burden. Right, you will remember, and one implication from that analysis was that it's desirable to spread taxes across all goods to keep tax rates relatively low on all goods. Right? However, there is one limitation behind that approach and that prediction, is that we actually consider the model just for two goods with only one tax good. So then making that implication is a little bit too far based on that simple model, right? So therefore, today we are going to discuss how exactly the tax burden should be spread across different goods. And for that, we certainly need a model with many goods. Right? So this is the idea for today's lecture. So what would be the difference between the economy with just two goods and the economy with many goods? From the perspective of our course, what is important is that a tax on one good affects not only this good demand, but also the demand on other goods, creating additional efficiency cost. Right? And we need to account for all these additional effects. And the question is then for us is how might the tax rate be set so as to minimize the cost to society of raising the required revenue. So the model that answers this question was proposed already a long time ago. It's a Ramsey model. You see it was in 1927, but it's still a very valid approach. And so we now going to discuss. So it certainly was like different researchers added a little bit to how to interpret this model, how to better to play, let's say it this way, play with this model, but it's like still a Ramsey model. So what is it about? So government needs to raise a given amount of revenue, and to raise this revenue, it can only levy commodity taxes at different rates on each commodity if it's wished. The government goal is to minimize excess burden when at least one good, say leisure, cannot be taxed. This is important, and we will emphasize this many times. And it's also important to know that taxing all goods at equal rate does not eliminate all distortions due to the presence of leisure. And we will kind of see this later. So the key assumptions would be there is no lump sum taxes. Right? We cannot tax all commodities. Leisure is untaxed always. Production prices are fixed, so this is just for simplification, and a representative individual framework that we are working. So more specifically on the assumptions. So there are end goods that can be taxed, and production prices are fixed and normalized to 1. So we will denote these production prices by PI. They're equal to 1. And the consumer prices will be denoted by QI. And it actually equals to producer prices, which is 1 plus taxes, which is TI. TI is a tax rate for commodity I. So all consumers are identical and face identical tax rates. This is a representative individual framework. And individual maximize his utility function. So this is the individual problem, right? So given by equation 1. So it's a maximization of utility that depend on the consumption of good 1 through n. It's x1, x2, and so on, xn, and also depend on, in this case, labor, right? So we can alternatively formalize it as on leisure, right? But it's just a one way to do that, right?
Excuse me.
Know that?
And what is L?
L is, yes, as you will now see, it's from the budget constraint, right? So let me read it. So the budget constraint is Q1 x1 plus Q2 x2 plus so on, Qn xn less or equal than WL plus Y. WL is wage rate, capital L is labor, as you can now see it's from the budget constraint, right? Because from the utility it's not clear. You could understand it from the utility if you would be given a specific utility and you can see whether this L affect the utility positively or negatively, right? Then you can understand what is L, right? If it's affect positively, then it's leisure. And if it's affect negatively, then it's a labor. But in this case, you can only understand it from the budget constraint. And a W here is non-wage income, right? Okay, so this is a consumer problem. He maximizes his utility function by choosing all Xi's and L label. So let's us write down the Lagrangian. So it's utility function plus Lagrange multiply alpha multiply the this WL plus Y minus Q1 x1 and C plus plus Qn xn, right, from the budget constraint. So we will now take the derivatives, right? So of this Lagrangian with respect to Qi and L. So to write down the first order condition. So we will end up when we take the derivative with xi, so we will have the derivative of u with respect to xi equal to Lagrange multiply alpha multiply qi. And this is for all I from 1 till n. And the last first order condition is the derivative of u with respect to L equal to minus alpha W. Right, so from this equation, right, from this first order condition, we can obtain demand functions, which is how Qi, right, the quantity or good I, depend on the prices. Note that Q now denote all the prices, including the wage rate, right? So I have it here a little bit later. And also how it depends on the non-wage income, right? Similar, the expression for the labor supply, right, of a person. So it's capital L, how it depends on Q and W1. Also, we can obtain now, calculate the indirect utility function, right, by plugging into the utility function the demand function we just found, right? So we will denote the indirect utility function by capital V, V of Q and W, right? So once we know the indirect utility function and the demand function, we can say that we know, we can describe the behavior of the consumer. So we know the solution of the consumer problem. One important remark here is what is alpha? Alpha, as you know, Lagrange multiply, it has a specific meaning. It's a marginal value of money for the individual. And it's equal to the derivative of the indirect utility function with respect to a non-wage income y. Okay. Okay, let's move on. So now we understand the behavior of the consumer, right? What is his demand based on the prices in the economy. So now we are ready to discuss the government's problem. The government solves his maximization problem, which is maximization of the indirect utility function of a consumer. Basically, he wants to maximize the utility of the consumer by choosing taxes, right? Taking into consideration the behavior of the consumer, right? So therefore, the problem like that is written as it's we maximize the indirect utility function by choosing taxes, or we can say not choosing taxes but choosing prices, because Q is price on tax goods is just 1 plus T, right? So there's no basic difference whether we choose taxes or we choose prices. The government is subject to the revenue requirement because the government need to collect taxes to satisfy some exogenous revenue requirement, right? So this is that, or the taxes from all taxed goods, it is equal to the sum from I equal to 1 till I equal to n of TIXI, and the sum should be greater or equal to R.
Excuse me.
Yes?
Who is our general?
It's just a constant in our problem, right? Is some exogenous requirement. In this problem, it's just given, right? So in practice, it's like there is a government budget or something like that, right? So they calculated that they need to collect that amount of taxes.
Okay, so
Because
it's just a budget. Let's call
yes,
it.
so Yeah, you can. And it's better to call it revenue, right? R, revenue.
Okay.
But it's some exogenous revenue requirement based on the consideration from the expenditure side, right? So they need to spend money on that public good, on health, on education, on that. They calculated that that's the amount of spendings, right? They understand now that they need to collect that amount of revenue, and this is what they are kind of working now, just calculating this revenue from taxes. Okay. So then Lagrangian for the government problem is in indirect utility function V plus lambda. Lagrange multiply this revenue requirement, sum of taxes minus R, right? Again, we take the first order condition by taking the derivative respect to Ti. So the first term will be the derivative of indirect utility function with respect to Qi, right? So as I mentioned, there is no difference between maximizing respect to Q or T, right? It's just mathematically the same. Plus Lagrange multiply lambda multiply the two terms in the bracket xi plus sum over g, g was from 1 to n of tg, maximize the derivative of xg with respect to qi. And this all should be equal to 0. So each term in this equation has meaning, and it always has, right? But in this case, we are going to discuss it. So the first term is actually a private welfare loss to individuals, right? How an increase in prices would affect the indirect utility function, right? So how it would reduce the people's or person welfare. Then the second term is a mechanical effect of increase in taxes on the tax revenue. So mechanically, an increase in tax rate would lead to an increase in the taxes. However, there is an additional effect on the tax revenue, which is called a behavioral effect, because XIs are actually not constant, right? The taxpayer, when taxes increase, they start to react, right, to the increase in tax rate and adjust his consumption, right? So this is the total behavioral response is equal to Tg multiplied the derivative of xg with respect to qi, where we sum over all g.
Excuse me. So derivative of v to qi, it's a private welfare loss to what? To individual or what?
Yeah. So this is V. It's the kind of utility of individual, just indirect utility, right? So it's measures the utility of individual. So it's how an increase in and derivative of it measures how an increase in prices affect this indirect utility function. So it's loss to individuals.
And one more question. So it seems logical that individual welfare loss can be derived as the sum of mechanical and behavioral effects. But why there is a sum of them? So
I'm not sure I quite perfectly understood your question. So let me give my answer, and then you will probably ask again. So first of all, the government cares about two things. It cares about the utility of individuals, but it also cares about the collecting revenue, right? It's not that we could consider in like different model with different types of the government, right? The government that cares only about revenue, the government that cares about people to some extent and stuff like that. So here the government is kind of perfect one, a social planner who cares about individuals, right? So therefore we have this indirect utility function in the government maximization problem. The weight with which the government weights the social welfare and tax revenue is represented by alpha. The Lagrange multiplier in this problem is reflect how much the government weight social welfare against the tax revenue, right? And then the effect of the tax revenue is due to change in taxes is characterized by two effects, mechanical effect and behavioral effect. Right?
So those effects, they are connected with government goal of maximizing the revenue, right? And the first derivative, it's about government cares about individuals' welfare, right?
Yeah.
Okay, thank you.
So there are three terms, right? The first term is about caring welfare, and the two other terms is about caring about tax revenue, right? Both mechanical effect and behavioral response effect. This is the effect on the tax revenue. You know, there I just mathematical there, right? So take the derivative of that sum, you will end up having just we kind of distinguish them so that better to obtain the better intuition, right? That we said at the very beginning that increase in QI affect not only this good, right? But it also affects all other goods. So, and all these effects are in this last term in this sum. The effect of QI on its own demand, but also on the demand of all other goods, right? Okay. This is, yeah, they are here in this third term.
Thank you.
Okay. Using now we need to recall some things from your microeconomics course. I would not stop much on this, right? If you just don't remember some of those equation, I will mention now. Just Google them, go to Wikipedia, and remind yourself, right? Because I sometimes does not remember them myself, but they are useful, right? It just kind of remind them to yourself, and it's just make sure you understand the kind of intuition behind those formulas. So using Roy's identity, which is the derivative of the indirect utility function with price Qi is equal to minus alpha xi. So we are going to plug it now into the equation 8 instead of the first term, and then rewrite this equation by recombining the first and the second term. So therefore we will have lambda minus alpha xi plus lambda multiply the sum of tg, the derivative of xg with respect to qi, sum over all g equal to 0. And this formula is actually a Ramsey formula. So it's rewritten a little bit differently here, but it's basically just it. So the sum over g, where g goes from 1 till n of tg, the derivative of xg with respect to qi, equal to minus xi divided by lambda multiply lambda minus alpha. So optimal tax rate satisfies system of the n equation, right, with n unknowns. The n equation is that we can write this formula 10 for each I, right? And I goes from 1 to n. And then it will give us tax rates. So we kind of done with the technical part, but the rest of the lecture we will spend on discussing and trying to understand the meaning, actually not just the meaning, but the intuition behind that formula. So first, let's start from considering a very special, very special case where the cross price elasticities epsilon ig is equal to 0 for all I that is not equal to 0. If this is the case, then in the sum on the left hand side of formula 10 there will be only one term where I is equal to g, right? And all other terms will be equal to 0. And then from that formula we can obtain the formula 11, which is called inverse elasticity rule, and it can be written as Ti divided by Qi equal to minus lambda minus alpha divided by lambda divided by epsilon I. So what is critical here is Ti is inversely proportional to the elasticity epsilon II. Right, so the minus here basically is just to cover the negative sign of epsilon II, right, the own price elasticity. And this is, again, this is from the inverse elasticity rule. The higher the elasticity by absolute value, the lower the optimal tax as a percentage of the original price. And this is basically the same as we already learned in the previous lecture, right? We said that dead weight losses are proportional to the elasticity, right? So we want so that to impose low. So to decrease that weight loss, we need to tax less those goods with high that have a high elasticity, or the other way around, so to tax more those goods that have low inelastic good. There is one problem there that we already mentioned it, that those goods with low with low elasticity, they are often elasticities, like full stop, closing. So this is there is a possible conflict with the redistributional goal, and we will talk about this, but from the efficiency perspective, right? If we don't think about redistribution goals. So this is what we should do, right? However, we want to provide some intuition for a more general case, right, when it's not that simple that the cross price elasticities are equal to 0. So for that, we will rewrite the Ramsey formula in terms of Higgsian elasticities to obtain further intuition. So from the Slutsky equation, right, we can write down that the derivative of xg with respect to qi is equal, right? This is basically breaking down the total effect into substitution and income effects, right? So the total effect, which is left-hand side in Formula 12, is equal to the substitution effect, which is the derivative of hg. Hg is a Higgsian demand. Higgsian demand Ag with respect to price Qi minus income effect, which is, plus income effect, which is minus Xi, the derivative of Xg with respect to non-labor income Y. Right, so one remark, in the previous lecture, Higgsian demand was denoted by X super C, right? Remember the superscript C. This is exactly the same Higgsian demand, but in this lecture denoted by H. So, you could wonder, right? Don't use the same notation. I probably could do that, but I didn't. I did this intentionally, right? It's that different textbooks use different notations, and you need to be able to kind of live this world with different notations. So you need to be able to recognize the thing, no matter by what letter it's denoted, right? So H is Higgsian demand in this lecture. By substituting the derivative of xg with respect to qi into our equation 9, right, in the second term. So we will obtain this formula 13. So it's lambda minus alpha xi plus lambda, the sum over g of tg multiplied the following bracket, the derivative of hg with respect to qi minus xi, the derivative of xg with respect to dy is equal to 0. So then we need to recall an important feature of a Higgsian demand, and actually it's usually called the symmetricity of a Slutsky matrix, which means that the derivative of hg with respect to qi is equal to the derivative of xi with respect to qg. You see that we just switch the indexes. The GI, we switch on IG, right? And if we then now plugged in this into the equation 13 and then recombine some terms, so now the first term and the third term in the formula 13 will be combined and moved to the right-hand side. So we end up with formula 14, which is 1 over xi multiplied the sum over g of tg of multiply the derivative of xi with respect to qg equal to minus theta divided by alpha. What is theta? It's a notation, a new notation. It's equal to lambda minus alpha minus lambda multiply the derivative of the sum tgxg sum over g, the derivative with respect to y. We need to discuss before we move on what is the meaning of theta. First of all, what we need to emphasize that is theta is independent of I, and it's actually measured the value for the government of introducing one lump sum tax of $1, right? $1 lump sum tax. So there are three effects, right, there of introducing $1 lump sum tax for the government, right? Again, the direct effect for the government of lambda, right? So by giving $1 to the government, so he value the income as alpha, right? So alpha is the marginal value of $1 to the government. Then there is a second effect, a loss in welfare to the individual of a magnitude alpha, right? So it's the second term minus alpha. And then there is this third effect, loss in tax revenue due to income effect, right? When we give lump sum tax to the government means that we take this $1 from the people in lump sum way, right? If people now have less money, so they would consume less, and therefore we will collect less through the consumption taxes. So this is loss in tax revenue due to income effect, and it's equal to the derivative of the sum of a g of tgxg, the derivative with respect to y.
Excuse me.
Yes.
And in that model, we suppose that we use both lump sum tax and
No. In this model, we use only consumption taxes. But the meaning of this formula would be that if we assume that we would take from the government just $1 as lump sum tax, we took from the individual $1 lump sum tax and give it to the government. Right? This is just a thought experiment, right? To understand the meaning of the theta.
Okay.
In the model, there is no lump sum tax. There are only consumption tax. But the meaning of theta is what would be the effect if we would, right? We don't do that, but if we would take $1 lump sum tax from individual and give it to the government.
Okay, so it's like about alternative way of things. Okay, I got it.
Yes, good. So then we are ready to rewrite the Ramsey formula. We already did it, right? But we're ready to interpret the Ramsey formula in this new look, right? So this is kind of also the Ramsey formula, but through the Hicksian demand. And why we did all these tricks is just to get this intuition. So let's work on this intuition. So let us suppose that revenue requirement R is small, and this is for the to ensure that all taxes are also small. Then tax TG on good G reduces consumption of good I, right? Holding utility constant. This is because we consider Hicksian demand, right? By approximately, right? The size of this reduction is DHI, which is equal to TG multiplied the derivative of HI with respect to QG, right? So then the numerator of left-hand side, this sum, right, it gives us the total reduction in consumption of good I, right? So each tax TG reduces the consumption of good I. So if we now sum up over all G, right, so then we sum up over all the effects on the demand of on the consumption of good I. So we will obtain the total reduction in consumption of good I. Then dividing by Xi yields us a percentage reduction in consumption of good I. This is called index of discouragement of the tax system good I. Then the Ramsey tax formula says that the index of discouragement must be equal across goods at the optimum, right? You see that the right-hand side of this Ramsey formula does not depend on I. So only left-hand side. This means that for all goods, this what we called index of discouragement should be the same, right? And what is this index of discouragement? The percentage reduction in consumption of good I due to all taxes, right? We introduce taxes on the goods, and each tax, right, whether it's its own tax or the tax on the other good, it's reduce cause a reduction in the consumption of that good. And if we add all these reductions, right, so then the percentage reduction in the consumption of good I should be so that it is the same over all goods, right? If we achieve that, this means that we chose taxes optimally, right? So we choose, our goal is to choose taxes optimally. When that occurs, when the percentage reduction in consumption of all goods is the same, right? This is kind of the intuition behind the Ramsey formula. So, questions?
So one more time,
Yeah.
on left-hand side, it shows us the total amount of consumption reduction of good I according to all taxes. So direct and
Yes,
indirect.
yes, it just percentage reduction, right? So it's a ratio of change to the xi, right? But
Okay.
yes, it's total reduction in the percentage.
So, and the right-hand side, how do we interpret it? It's just the coefficient?
Yes, just this, it has meaning, we discussed it, but what is matter is just a constant. It does not depend on I, so that for all goods, the percentage reduction should be the same.
Okay, so, and this is the the statement of optimum. So if
Yes.
if the reduction is different for some goods, we're not at optimum, right?
Yes. Yes.
Okay.
Okay, good. So let us play a little bit more with the Ramsey formula. Now we will introduce elasticity to write the formula we discussed. So let us introduce the compensated elasticities. It's exactly the same, just we take the derivative with respect to Hicksian demand. So epsilon Ig compensated is equal to Qg divided by Hi, multiply the derivative of Hi with respect to Qg. Then we can write the Ramsey formula as sum over all G of Tg Qg multiply the derivative of epsilon Ig, sorry, I said something wrong, multiply the compensated elasticity epsilon Ig, and this is equal to minus theta divided by lambda. Again, the simplest case in this situation will be to consider a case where all cross price, there's no cross price effect, all cross price elasticities are equal to zero, specifically compensated elasticity epsilon Ig equal to zero. Then we obtain again the inverse elasticity rule in terms of compensated elasticity, and it is just Ti divided by Qi is equal to minus theta divided by alpha divided by epsilon II, right? The compensated elasticity epsilon II. So this is kind of the same, but in terms of Hicksian demand. Let us additionally suppose that it's not only that all cross price elasticities are zero, but also that all goods have same complementarity with leisure. This is that compensated elasticity between I and leisure. This XIL, right? So you see these indexes, it's XIL. The elasticity XIL is constant for all goods. Then what we can obtain, if we recall another property of the Slutsky matrix, that is the sum so let me explain first, it's more generally. You see this S multiply Q equals to 0, it's in a matrix form. So matrix, Slutsky matrix S, we multiplied by vector Q and obtained a vector, right? And this vector is equal to 0. If we take just one row from that, matrix multiplication, what we will have is that the sum of G, where G goes from I till n of epsilon Ig plus epsilon IL, right? So it's XIL should be equal to 0. So we basically fix one index and then sum over all other goods, the elasticity, and then it should be equal to 0. In our case, right, we have all elasticities where I is not equal to G is equal to 0. So therefore, there are just two terms are left, epsilon II and epsilon XIL, right? The elasticity between good I and leisure. because this shows that epsilon II is equal to minus epsilon IL, right? So the elasticity between leisure and good I. And if we plug in into this formula 19, then we obtain that TIQI is just inversely proportional to this compensated elasticity between epsilon IL, right? So that measures the relationship between good I and leisure. But we assume that it's the same for all goods, right? Reflecting the fact that there is the same complementarity with leisure for all goods. Then we can say that if all the goods have the same degree of complementarity with labor, leisure, or whatever, then TIQI is constant. Which what does it mean? This means that we have uniform taxation, right? All tax rates are the same. But what is surprising, right, is that we need to assume so much, right? There's so much assumption behind that result, behind this uniform taxation. So then, in general case, we likely would not have uniform taxation as an optimal setting. Then you might start wonder, why do we have in practice uniform taxation, right? Wait a little bit, we will discuss that. But from the efficiency perspective, right, from our model, which take in consideration the efficiency issues, right? So we only cares about what is efficient, what is not, right? What is the efficient way to set up consumption taxes. From these efficient considerations, uniform taxation is likely not the optimal setting, except there is this very special case. Okay. Let us consider this I will say example that called Harlett-Hagi rule to get even further intuition, right? So let us assume there are three goods. To simplify our life with notations, so let us now denote leisure by x0. And the two other goods would be again x1 and x2. So leisure is untaxed numerator, meaning that q0 is just equal to p0 and tax rate t0 is just 0. Then we can apply Ramsey formula in these settings, right? So what would the Ramsey formula be in these settings, right? So if I is equal to 1, then in this sum, G goes from 1 till 2, right? There is only just two terms where epsilon is equal to epsilon 1, 1 multiply T1 divided by Q1 plus epsilon 1, 2 multiply T2 divided by Q2, and this is equal to the constant minus theta divided by lambda. And the same things we can do for the second good, when I is equal to 2 and G runs from 1 till 2. Then from those two equations, right, Ramsey formulas, we can calculate the ratio of T1 Q1 to T2 Q2, and it would be equal to the following. So in the numerator there will be epsilon compensated elasticity epsilon 1 2 minus compensated elasticity epsilon 2 2 divided by the difference between epsilon 2 1 and epsilon 1 1. Now again we will use this property of the Slutsky matrix that I explained you in the previous slide, but with this notation it's we can easily write it, right? So it's easy to express it. So it's mean that for example epsilon 1 0 plus epsilon 1 1 plus epsilon 1 2 is equal to 0. The same thing we can write for the index for the second root, which is epsilon 2 0 plus epsilon 2 1 plus epsilon 2 2 would be equal to 0. Now deriving epsilon 1 2 from the equation I have here on the slide and plugging into the numerator and then do the same stuff for the denominator, we would obtain the formula here on the top of the slide. So the ratio of the relative tax rate T1 divided by Q1 to the ratio of T2 divided by Q2 is equal to what we have here in the right hand side. In the top we have epsilon 1 1 with a negative sign, minus epsilon 2 2 minus epsilon 1 0, and in the denominator minus epsilon 1 1 minus epsilon 2 2 minus epsilon 2 0. So the difference between the numerator and denominator is in this last terms, right? Epsilon 1 0 and epsilon 2 0. So, and this is the relation, reflect the relationship between good 1 and leisure and between good 2 and leisure. So again, this the case when epsilon 1 0 equal to epsilon 2 0 is the case that we already considered, and in this case T1 is equal to T2, meaning that we have a uniform taxation case. We also could have the case when they are not equal. For example, it could be that epsilon 1 0 is less than epsilon 2 0, meaning that good 1 is more complementary to leisure, right? So it's react more when we change the price of the leisure. And in this case, we would end up that it's optimal to have T1 greater than T2. What does it says? It says that we want to tax more that good that is more complementary to leisure, right? So it's optimal to tax more that good that is more complementary to leisure. This is basically mean that leisure could be indirectly taxed by subsidizing I don't want to say that. Leisure can be taxed indirectly more by taxing more those goods that are complementary to it. And I want just to emphasize that we see also that uniform taxes will not be optimal unless substantial and typically unrealistic restrictions are imposed on preferences. So this is kind of the basically the end of the story. We dig so far so that we now understand, right, that the key issues is that whether we cannot tax leisure, right, in this model, and therefore we have distortions, right? So we cannot tax all the good, including leisure, and therefore to compensate for that, we want to tax leisure indirectly by taxing more those goods that are complementary with leisure. But nevertheless, right, this is very insightful model, but it's still a model, so it's meaning that it has some drawbacks, or have some things that left out from the model. And this is also a way to understand why there is this disconnect between our prediction from the Ramsey model and the practice we have, right? So I mentioned to you that in from the Ramsey model, from the Ramsey consideration, uniform taxation is likely not optimal. But we do have a uniform taxes in practice, right? With just probably small exclusion, right? So we valuated tax we have in Russia. It's as I remember, 20%, right? On most of the goods. There are some exclusion. There is some goods taxed at low, but this is due to redistributional consideration, not any other considerations. So why is it so? Probably the key reason is that there are administrative and compliance costs that we do not include in the model. And uniform taxes are probably much more cheaper to administer than any other taxes. Also evasion, right? If we tax different goods at different rate, then people would try to cheat on those rules and try to find ways how to kind of trick this system. Then other reasons is that there is presence of other taxes, income taxes on factors, and all other taxes. Open economy considerations that we do not include in model. Can burden be shifted to non-residents through export taxes? Also, it doesn't account for externalities. Right? So some goods can produce externalities, and we probably want to reduce those externalities by using consumption taxes. We don't account for that. And then, as always, availability of information is an issue. How do we obtain these elasticities to kind of base our taxes properly, right, according to the optimal formulas we derived, right? So all these issues are serious issues, but nevertheless, right, so the Ramsey model is an important model for us to understand the fundamental things what matter for efficiency consideration. So let me give you some funny, or maybe not that funny, examples of avoidance of commodity taxes when there is some non-uniform taxes that are used. In Indonesia, cars are taxed at a lower tax rate than motorcycles. And as a result of that, a new type of motorcycle with three wheels and long benches at the back sitting up to 8 passengers appeared. Right? Why? Because of tax system and because people try to avoid taxes. In Chile, again, the car was taxed more than a truck, and as a result, a redesigned handle truck with glass windows and upholstered seats in the back appeared. Right? So we see that people are creative. Also, the other limitation of the Ramsey formula that we already mentioned, and I promised you to come back to this, is that through the Ramsey formula we said that we need to tax inelastic good to minimize efficiency cost. But then we see the problems with redistributional motives. Right, because necessity likely to be less elastic than luxury goods, and right, this kind of unfair because usually poor people consume more necessities. But actually, this is not that serious limitation of the Ramsey model, because we can take this into account relatively simple, and this is what we are going to discuss now. This was kind of first done by Diamond. He extended Ramsey model to take redistributive motif into account. And this is a simple model how to do that, right? So let us consider not just the representative consumer, but two consumers who earn different incomes. We will index the consumers by age, household 1 and 2. The utility of each consumer is as before. Depend on the consumption of good 1, 2, and so on, and the leisure. For simplicity, will be denoted by X0. Then we need a social welfare to understand how we social welfare depend on the utility of the first and the second consumer. So the social welfare function is denoted by W, and it's depend on the U1 and U2. And then the government revenue constraint is that the government need to collect some amount of revenue R from the taxes. The first sum is the taxes from the first individual, and the second sum of the taxes collected from the second individuals. So what the government does, it maximizes the social welfare function subject to the revenue constraint, right? So it does so by the first step should be done. So we need to solve the utility maximization problem. This is basically we understand, we derive the indirect utility function of each consumer, then plug in the social welfare function, and then maximize the social welfare function subject to the revenue constraint with respect to tax rates, right? Then if we do that, we obtain the first order condition for each good I. This formula basically that formula that we discussed intuition. The first term is welfare loss to all the individuals, right? This is the effect on the government Lagrangian, right? So the first term is reflect the yes. So let's me just to repeat it: the welfare laws to individuals and government care about this, plus the effect on the tax revenue, which include the mechanical effect and the behavioral effects, right? So you can read the formula. And to obtain a result that is easily comparable to the Ramsey rule, let us define beta H, which is the derivative of the social welfare W with respect to VH, its indirect utility function of the consumer, multiplied by alpha H. Alpha D is by analogy Lagrange multiply in the consumer problem. And beta H is just the social marginal utility of income for consumer H. Okay, and skipping some steps, we can obtain the formula for the optimal tax rate, which is would be analogous to the Ramsey formula in these settings. So the left-hand side is basically the percentage reduction in the consumption of good I. So it's kind of the same thing as in the Ramsey formula, but right-hand side, unlike Ramsey rule, is not independent of I, right? So meaning that percentage reduction is not the same for all goods. So from the first term on right-hand side, we can see that the proportional reduction in demand for good I will be smaller the larger the value of this term, which is beta 1 multiply x1i plus beta 2 multiply x I2 divided all this divided by x1i plus x12. When this term is larger, it's larger when a higher beta H is correlated with a higher HIH. If the social welfare is concave, we mean that we care about redistribution, then beta IH is higher for low-income individuals. This means that these terms is larger for those goods that consumed more by poor individuals. And this means that proportional reduction in demand for a good will be smaller if it's consumed primarily by the poor household.
Excuse me.
Yes.
Could you please repeat what is the difference between that approach, Diamond approach, and Ramsey rule? So,
yeah, we just ended one additional consumer. Right? Everything is the same, but in Ramsey, there was just one representative consumer, just one consumer. Here, we added the second consumer, and this subscript 1 and 2 reflect the indexes of a consumer.
okay, and so our results are not the same. So the percentage reduction is not the same for all goods, and any other differences?
Yes, but we try to understand. We understand that it's not the same, but then which goods should be taxed more, which goods should be taxed less, right? And we understand that from redistribution perspective, like logically, right, we should tax less, so it's good that consumed more by poor individual, right? So we kind of does not want to hurt poor individuals that much. If they indeed consumed a lot potato, we shouldn't tax much potato, right? And this is exactly what we are getting from this formula, right? We're just trying to see this, how does that appear, how that shows up from this formula, right?
Okay.
So we are looking at this first term in the right hand side, and this third bullet, right? The proportional reduction in demand for good I will be smaller the larger is the value of this term. And this is exactly this first term on the right hand side. So we're trying to understand when this term is smaller, when it's larger.
Okay, so smaller taxes for...
Yeah, so to understand this, we need to remember that the left-hand side is negative, right? There might be some confusion. Be smaller, the large is the value of this. The left-hand side is negative, and so it's -1 plus this, right? So the negative, so just try to think about this one more time when you just alone, but it's negative, it's -1 plus something. It would be low if this term is larger.
Okay.
Right? Then what we just need to do is understand when this term is larger.
Okay. As is written, it is the larger are the values of b. Multiply those.
Yeah. And the critical thing now is to understand that this occurs when higher beta H is correlated with a higher XIH.
Okay.
And this could happen if we live in a settings when the social welfare function is concave, meaning that beta H is higher for low-income individual, right? So this is just take as a given.
Okay.
Right, so the concave for the concave social welfare function, we would have a higher weights on a low-income individual.
Okay.
But then when we have those beta H, this term, right, we discussed would be larger for those goods that are consumed primarily by the poor individuals, right? Because then there would be the highest beta H multiplied by the highest consumption, and this occur for those goods that consumed primarily by those poor individuals.
Okay. So it's logical then we don't want to tax a lot poor individuals. Okay.
Yes, this is kind of we understand this from the kind of without this model, right? So we kind of start from this problem that in Ramsey setting, what we end up is that we eventually tax a lot those goods that are necessity, and this is those goods that consumed primarily by poor individuals.
Okay.
Kind of problem, right? We now have this diamond model, and we understand that in these settings, this problem is fixed, right? Because what we obtaining is that we indeed want to have low taxes on the good consumed by poor relative to those that consumed more by rich, and this is determined solely by efficiency consideration. No. I'm just reading the slide. So the essence is that we kind of fixing, adding equity consideration into our efficiency setup, right? The Ramsey model is pure efficiency consideration. Diamond model is adding redistributive consideration in addition to efficiency consideration, right? Because we have two people with different incomes, so we care about the redistribution of income between them. And so now we see that with adding this redistribution consideration, we indeed fixing that issue, that and we end up having low tax rates on those goods consumed by poor individuals. So there is no problem with the redistributive motives.
Okay. Yes, it is clear now.
Good. And so that's...
Sorry.
Yeah.
We have 3 minutes before our next lesson.
So I'm ready to done. I'm ready. Sorry about that.
Okay.
But let's just finish. Okay. So I just ready to say you bye-bye, and sorry again, it took more time. Okay.
Okay. Thank you for the lecture.
Yeah, thank you.
Goodbye.
Bye-bye.